Hi, and welcome to the second of two videos for section 10.9. Again, a quick recap of what we've been doing so far with chapter 10. 10.1, systems of linear equalities, linear equations with two variables. Section 10.8, solving nonlinear equations. So we had parabolas and lines, where do they intersect? And now in 10.9, we're solving inequalities. And so the steps to do this, so for solving a system of inequalities, first we're going to solve and shade each inequality separately . And the solutions are the areas, or maybe is, so let's say the solution is the area of overlap. And then 3, to find the vertices, so to find where they intersect, solve the system of equations corresponding to the inequalities. So if, for example, I have a parabola and a line, and I want to know the solution set, I find out where's the overlap, and then if I want to find what are the points where they're intersecting, it's like we did in either 10.1 or 10.8, depending if we have two lines or nonlinear equations. So let's look at an example. Want to solve, so let's call this part 1. Solve this system of inequalities. System of inequalities. X squared plus y squared is less than 25, and x plus 2y is greater than or equal to 5. So I'll use different colors here. I'll switch to green when we get onto the line there. All right, so let's graph this guy. The first one is like the example that we ended with in video 1, right? It's our circle, dotted line, radius of 5, and it was shaded inside. So the blue one here is equation 1, the circle. Now, for this one, it's a line, so I'm going to solve for y. So if I subtract x from both sides, I get what? 2y is equal to negative x plus 5. So divide everything by 2. I get y equals negative 1/2 x plus 5/2. So that means my y-intercept is at 5/2, which is 2.5, which is here. Because it's greater than or equal to, this means what? It means it's a solid line. And then my slope is the value in front of the x. So that's down 1 unit over 2. So down 1 over 2. down 1 over 2. So I get this line here. Now, as before, I need to pick a test point. So fortunately, I can choose 0, 0. It's not on the line, so if I test 0, 0, if I plug it into this inequality, what I get? 0 plus 2 times 0, is this greater than or equal to 5? Well, that's 0 is greater than or equal to 5. That's false. That is not a true statement, which means I don't shade the side with 0, 0. I don't shade the bottom left side. I have to shade the the top part of it, which technically it's all of this, right? So I should probably do this. So it's everything on the top side of this line. That's the green area. So that's what I did. Step 1, solve and shade each inequality. The first one is the circle with the shading blue inside. The second one is the solid green line, and everything above the line satisfies that. So the solution is the area of overlap, which would be what? It's this solid line to this dotted part of the circle, and it's everything inside of here. So the red is my actual solution for this system of inequalities. It's this part of the circle with the line is solid, dashed around the outside, all the shading to the inside. So let's call that part 1. Part 2, so I'm going to erase the writing here so I can keep the problem on the board. So part 2 says, find the vertices. So what this means is they want to know what's this point and what's this point, where the two figures or two inequalities intersect, the line and the circle. So I'm going to solve these guys as if they were equations. So I have what? X squared plus y squared is 25, and x plus 2y is equal to 5. So in this case, again, I can do substitution or elimination. I'm going to solve this one for x. If I subtract 2y from both sides, I get what? X is equal to 5 minus 2y. Now I plug that into the original. So I get 5 minus 2y squared, because it's x squared, plus y squared is equal to 25. Foil this one, I get 25 minus 20y plus 4y squared plus y squared equals 25. So subtract 25 from both sides to get rid of it from the left side. This is gone. It also happens to be gone now on the right. On the left, I have 4y squared plus y squared is 5y squared minus 20y is equal to 0. Divide everything by 5 to make the numbers easier for me. So I get y squared minus 4y equals 0. Factor out a y. So I get y times y minus 4 is 0. Come up here with it. So that means what? By zero property rule, y is equal to 0. Y minus 4 equals 0. So that means y is equal to 0, or y is equal, not 5, 4. Y is equal to 4. So those are my two values for y. I need to figure out what are the corresponding values for x. So when I plug in y is equal to 0, if I use this equation here, I get what? X is equal to 5 minus 2 times 0, which is 5 minus 0, which is 5. So one of my solutions is 5, 0, which makes sense because that's this point right here, right? It looks like where the intersection of our graph is, so that's good. These points that we come up with should more or less look to like what we have on our graph. When y is equal to 4, I get what? X is equal to 5 minus 2 times 4, 5 minus 8, which is negative 3. So the second point, so one point is 5, 0. One point is negative 3, positive 4. Does that make sense? So negative 3, positive 4. Yep, actually there's my 4. It comes out pretty close to where that is. And that's what it should be. You should get, these points are roughly like what it looks. If I would have gotten an answer of negative 3, negative 4, well that's where? Negative 3, negative 4 is down here in quadrant 3, so that doesn't make sense. I should have gotten a point that's roughly there and roughly there, depending on how accurate my graph was drawn. All right, so the last little bit of, so I'll leave that, I'll just erase this. The last little bit from this section and the end of this video, video 2, is just talking, probably should have left that. That's okay. So we have the definitions and the idea of bounded versus unbounded. So as the name implies, so when a region can be covered by a circle of any size, doesn't matter, covered by a circle, it is bounded. So as the name sort of implies, it has boundaries. And if not, it is unbounded. So in this example here, I'll try to draw it back real quick. So this was our solution set. So is this one bounded or unbounded? Well, if I draw a circle this big, it covers that area, so it's bounded. What's a solution set that's unbounded? Well, let's think back to our parabola. If I had the parabola that was shaded inside of here, I can't draw a circle that'll cover the region, right? Because if I draw, oh, I'm going to draw a really big circle. Okay, it covered it. Well, not really. Why? Because this thing keeps going to infinity, so this area is still part of the area, and it doesn't matter how big I make the circle, I can keep drawing shading outside of that circle to test. So that would be unbounded. So again, just sort of a definition. The easiest way to think of it, does it have boundaries? Yeah, then it's bounded. Does it have boundaries? Well, not on the sides, but not on the top, so it's unbounded. So that's it. That's the end of video for 10.9. Come on back and we're going to look at the video for 10.3.